Last time we finished on finding finding the area below the graph of a function f above an interval from a to b. So if f is not negative, then we know that the area A is given by the definite integral of f on the interval from a to b. If f is not non-negative, then what we know is that the definite integral of f from a to b gives you the net area between the graph of f and the x-axis. Okay. We're going to use this today to evaluate some definite integrals. So let's say I want to evaluate this integral here. One thing I want you to know is that when you go to Calculus 2, you'll see how to deal with a root function like this in a different way by using some substitution rules, which requires that you know inverse trigonometric functions. But since we don't know inverse trigonometric function at this point, we're not going to do that. You will do that in Calc 2. But the way I want to evaluate this integral now is by interpreting it as an area. Okay. So this definite integral, what is the integrand? Is the integrand a continuous function from 0 to 1? What do you think? Is your integrand continuous from 0 to 1? Well, remember, root functions are continuous on their domain, right? So is this integrand defined for x between 0 and 1? The answer is yes, because if x is between 0 and 1, x squared is also between 0 and 1, and 1 minus that is positive. So there is no possibility of getting a negative number inside the root when x is between 0 and 1, right? So I know that the function is continuous, so I know that the integral exists, right? And so I also know that the value of this definite integral would be the net area between the graph of the integrand and the x-axis over the interval from 0 to 1. So I need to come up with the graph of that integrand between 0 and 1. So how would I do it? Does anyone know what's the graph of this integrand function? So I'm going to let y to denote the integrand here, and so can someone tell me? So here x is between 0 and 1, right? X is between 0 and 1. That's my integrand function. Is this what's the graph of this function? What is the graph of this function? Anybody remembers? Well, let's do some more work then. Let's square both sides. So I get y squared is 1 minus x squared. Do you know what's the graph now? What is it? Circle. So this is x squared plus y squared is equal to 1, right? And so what do I see? I see that the graph of my integrand is a part of the circle, but what part of the circle? Can someone tell me what part of the circle am I getting here? So let's say that this is a circle of radius 1, right? Centered at the origin. You agree with that? X squared plus y squared equals to 1. That's the circle of radius 1, centered at the origin. And what part of the circle do I get? This quadrant 1 part? Yeah, here is negative 1, here is positive 1, right, on the x-axis. And the part, we get this part here. We are getting the part of the circle on the lying on the first quadrant, right? Because x is between 0 and 1, and notice that the y value is positive, right? Y is the positive root of 1 minus x squared. So the graph of this guy, right, is the upper half of the circle if x is between -1 and 1. If I put a negative in front of the root, then I get the lower half, right? But because x is between 0 and 1, I get 1/4 of the circle. Okay, so that's the circle. Then what is represented by? What does the integral represent then? What does the integral represent? The integral represents the area below the graph of the integrand above the interval from 0 to 1, right? Do I know what that area is? What is that area? What is that area? Well, what is the area? This is 1/4 of the area of the entire circle, right? What's the area of the entire circle? Don't tell me you don't know the area formula for the circle. What's the area of the circle? Pi r squared. R is what here? 1. So it's just pi. The area of the entire circle is pi because the radius is 1. So this would be 1/4 of pi. Is everybody okay? 1/4 of the area of the entire circle. Everybody's okay? Alright, so let's do another example. Let's look at this integral here. Integral from 0 to 3 of x minus 1 dx. Okay. Once again, at this point, we don't have any way of evaluating definite integrals except for estimating them with Riemann sums or taking the limits of Riemann sums and try to come up with the definite integral. But this is another way I can interpret the integral in terms of an area and see if I can compute the area. And of course, I cannot do most problems by using this idea, right? Why? Because I am lucky in the case of the circle, because I know the area of a circle. I'll be lucky in this case as well, but there are many other problems where, just look at the graph of x squared, right? If I tell you what is the integral of x squared between 1 and 2, right? What did you say? Well, you don't know a formula. Well, that's precisely the point. You're defining. You want to compute the integral to come up with the area. Okay? Am I making sense? So let's see in this case what's the area. Well, what is the graph of x minus 1? The graph of x minus 1, you realize, is a line, right? So the y equals to x minus 1. What's the graph of that? How do I, between 0 and 3, right? So when x is 0, what is y? When x is 0, what is y? -1. So that's why I get the point at -1 right here. Okay? And when x is 3, what is y? 2. So this height here is 2. And this height here was -1, right? And once I have 2 points on the line, I can just join them and I get the graph of x minus 1 for x between 0 and 3, right? X is between 0 and 3. So now, what does the definite integral represent? What does the definite integral represent? The definite integral in this case, this function is not non-negative, right? So in this case, the definite integral represents what? Net area, right? So what's the net area? Well, it is the area A2 minus area A1, right? Can someone tell me what is area A2? So this would be equal to A2 minus A1, right? What's area A2? What is area A2? What did you say? Because it is half times base times height, right? So base is 2, the height is 2, so half times base times height is 2 exactly. And what's the area of A1? Well, again, half times base times height. Height is 1, the base is 1, so it's half, right? Everybody is okay with that? So the A1 is equal to half, and altogether, what am I getting then? 3/2. Is everybody okay? Alright. Now there might be some homework problems where you have to interpret the definite integral as an area and then compute the area to come up with the value of the definite integral, just like these two problems. Okay. Any questions at all? I want to give you another application of there are so many applications of definite integrals, but one of the examples would be this. Suppose that f of x denotes the instantaneous speed at time x over the time interval from A to B. So suppose we are looking at the motion of some object, and the instantaneous speed of that object at time x is given by the function f of x. And let's say you're asked to find out what's the total distance covered by the object over that time interval. Is my question clear? So you know the instantaneous speed of the object that is moving, and you need to come up with the total distance covered by the object over the interval from A to B. So how would you do it? Well, first of all, let's see how we can estimate that. You have the interval from A to B, right? That's the time interval. Let's divide it, let's take a partition of that. So let's take n to be pretty big, right? N is very big. So you partition it into many subintervals, and let's say all these subintervals are very tiny, okay, because n is big. And so what would be my so in this case, once I pick a partition of the interval, I pick sample points w1, w2, wi, wn. And now the thing is, because these subintervals are so tiny, so if the first subinterval is so tiny, what is f of w1? What does f of w1 tell you? F of w1 tells you the instantaneous speed at time w1, right? F of w1 tells you the instantaneous speed at time w1. So that's not the average speed over the first interval, right? But because the first interval is so tiny, I can assume that f of w1 gives you the average speed over that time interval. So if I assume that f of w1 is the average speed over the first subinterval, then what's the distance covered over the first subinterval? If I give you a time interval, if I tell you the average speed of the object, can you give me the total distance covered over that time interval? What is that? Rate times time. Rate times time will give you the average rate times time will give you the total distance. So think about the ith subinterval here, wi. Again, f of wi is the instantaneous speed, not the average speed, because the ith subinterval is so tiny, I can assume f of wi is an approximation, is a good approximation of the average speed over that interval. So then I can, if I multiply f of wi with the length of that ith time interval, if I multiply the length of that with the rate f of wi, I get an approximate value of the distance covered over the ith subinterval, right? And then if I sum over all these intervals, right, the summation I going from 1 up to n, f of wi delta xi, if I look at that sum, that would be an estimate for the total distance covered over the interval from A to B. This type of things are done again and again and again in physics, for example. When you try to define work and many other quantities, you use Riemann sums, and then you say, oh, well, the Riemann sum, if I take the limit of that Riemann sum, what do I get? Well, I get the integral of what? If I take the limit of this Riemann sum, I get the definite integral of the speed function, right? That's how we define definite integrals. So I know that if I integrate the speed function over an interval, that gives me the total distance covered by that moving object over that time interval. Is everybody clear? So that's an application of definite integrals, is that given the speed function of an object, you can come up with the total distance covered by the object over a time interval. Is everybody okay with that? Everybody's okay? All right. There are some algebraic rules for definite integrals which are pretty much the same as the ones that we've seen for indefinite integrals. So if I am integrating from A to B and I'm integrating the function c times f of x, where c is a constant factor, then the constant factor can be taken outside of the integral. So the integral from A to B of c times f of x is the same as c multiplied by the integral of f of x, which is, so basically number one is allowing you to factor out a constant factor, right? It is allowing you to take out the constant factor outside the integral sign. Number two says if you have a integrand where the integrand has bunch of summands, right? The integrand has bunch of summands. You can integrate one summand at a time, right? You can integrate one summand at a time. You can integrate term by term. That's another way of saying it. So integral of f of x plus g of x is the same as integral of f plus the integral of g. So you can integrate f and g separately. And if you remember, we had the same rules for indefinite integrals as well. And also, if you think about it, we also had the same rule for derivatives, right? We had the same rules for derivatives. So to show you why these two theorems are important, we sort of, most people will use these two rules without even realizing, what allows them to do that. Okay, for example, if I have this integral from 0 to 1 of 3x squared plus the root of 1 minus x squared, right? If I have this integral, what can I say? Well, by using my second rule, instead of integrating the whole thing, I can integrate term by term, right? So I can integrate 3x squared and I can integrate root of 1 minus x squared separately, and then I can when I look at the first integral now, the integral of 3x squared, rule number 1 says if you have a constant factor, that can be taken outside. So the 3 that I have there, it can be taken outside of the integral. And if I do that, then I get 3 times the integral from 0 to 1 of x squared dx. and I also have the integral from 0 to 1 of root of 1 minus x squared dx. Now, anyone remembers what's the integral from 0 to 1 of x squared? Remember yesterday we computed the integral of x squared from 0 to 1. What was that? 1/3. And just a few minutes ago, we evaluated the integral from 0 to 1 of root of 1 minus x squared by interpreting that as the area of 1/4 of the circle, right? So we know that the area of the first integral here, this guy is 1/3, this guy is 1/4 of pi, and then if I add them, I get 1 plus pi over 4. Is everybody okay with this example? You guys are okay with that example? Again, I haven't really shown you how to compute definite integrals. The only way we know so far is by dealing with Riemann sums directly, or by interpreting the integral as an area, and hopefully you know how to compute the area, because even for functions like x squared, right, you don't know how to, you don't have a formula unless it's a triangle or a circle or a rectangular region, right? You don't know exactly how to compute those areas, right? So, but that's the point, that the definite integrals allows us to compute areas, right? Am I making sense? Okay, so here's another theorem. If I integrate a function from a to a, f of x dx, then that integral should be 0. Can someone give me an argument for why number 1 is true by using Riemann sum? Remember, the integral is the limit of the Riemann sums, right? The integral is the limit of the Riemann sum as the mesh goes to 0. So can you tell me why this integral is 0? You know, one thing for sure, if you look at this integral represents certain area, right? The net area between the graph of f and the x-axis above the interval from a to a, right? Which is what? Which is 0, right? Empty region, right? Which is just a line, right? What's the area of a line? 0, right? Unless it's a two-dimensional object, the area would be 0, right? So, but I want you to give me an argument using Riemann sums. So here's what I want to ask you. If I look at the Riemann sum of this function, what's the value of the Riemann sum? Do I know the value of the Riemann sum? If I look at the Riemann sum of f over the interval from a to a, what's the value of the Riemann sum? Write down the Riemann sum for the function and tell me what is the value. Very good. If you look at the Riemann sum, right, for this function, the Riemann sum will be the Riemann sum would be like this, right? I going from 1 up to n, f of wi times delta xi. But what is delta xi? Remember, delta xi is the length of each subinterval, right? But in this case, the whole interval has length what? 0. So each subinterval has length 0. So each one of them is 0, which tells you that no matter what partition you have, every single Riemann sum has value 0, right? So if you take the limit, you get 0, right? So this integral is got to be 0. Is everybody okay with that? The next one, the next one is for any constant c, the integral from a to b of c dx is basically c times b minus a. So this is telling you how to integrate constant functions, right? If I have a constant c as the integrand, then the integral is simply that constant multiplied by the length of the interval from a to b, b minus a, c times b minus a. Is everybody okay with that? So geometrically it makes sense. Why? Let's say c is positive, right? If c is positive, then the graph of the constant function c will be y equals to c. And what can you say? What can you say between a and b, right? The integral represents the area below the graph, above the interval from a to b, right? Well, that means that the integral represents this area, doesn't it? And what's the area? Well, it's a rectangle, right? So the length of the rectangle is b minus a. The height is c. So if I multiply them, I get the area of the rectangle. So the definite integral of c should be that area. Is that making sense? Is everybody okay? In fact, can someone tell me, if I look at the Riemann sum, if I look at the Riemann sum of the constant function c, what's the value of the Riemann sum? If you can answer that, whoever answers that first gets some extra points. Okay. If you can answer that now, I will give you extra points. The question is, if you look at the Riemann sum of the constant function c from a to b, write down the Riemann sum, think about the interval from a to b, look at the partition, and you're evaluating the Riemann sum, what's the value of the Riemann sum? You can tell me what's the value of the Riemann sum in terms of c, a, and b. It's not going to be a number, of course, because we don't know what c is, and we don't know what a and b is, but you should be able to tell me what's the value of the Riemann sum in terms of c, a, and b. Look at the Riemann sum from a to b of f and tell me what's the value of that Riemann sum. Write down the Riemann sum. Think about what would be f of wi. Think about what would be f of wi. And then think about how the sum, what the sum should be. What are you summing? I'm sorry? B minus A? No. Okay, very good. C times B minus A. Okay. So you get some extra points, okay? You should talk to me after the class. Okay, so the point is, if I look at the, see, remember, if I have a partition of the interval from A to B, if I look at a sum, f of wi times delta xi, right? I going from 1 up to n, right? What is f of wi? Well, f of wi is c, right? Because f is the constant function c, right? So this would be the what? This would be the sum c times delta xi, right? But because c is a constant factor, I can take it outside of the sum. And then I have the sum of delta xi, I going from 1 up to n, right? But wait a minute, what's the sum of the delta xi's? What is delta xi? Delta x1 is the length of the first subinterval. Delta x2 is the length of the second subinterval. Delta x3 is the length of the third subinterval, right? If I add up all the lengths of the subintervals, I get the entire length, right? What is the entire length? The entire length is b minus a, right? So the value of each Riemann sum is c times b minus a. So of course, if I take the limit as the mesh goes to 0, or as the number of partition points goes to infinity, the limit will be the same, because each Riemann sum has the same value. Is that making sense? Okay. Now, so far, when we defined the definite integral, we defined it where a is less than b, right? We took an interval from a to b, and we defined what does it mean to what is the meaning of the definite integral from a to b, right? That's what we defined. But it is also useful to think of integrals where the lower limit is bigger than the upper limit. So far, the lower limit of the integral is smaller than the upper limit, right? A to b. So a is smaller than b, right? But it is also helpful to do the other way, b to a, where b is bigger than a. Okay. So how would what would be the meaning of an integral from b to a of f of x dx where b is larger than a? Well, it's just going to be the negative. It's going to be the negative of the integral from a to b of f of x dx. Am I making sense? So let me give you a quick example here. Let's say I have the integral from 1 to 0 of root of 1 minus x squared dx. Well, this integral will be the same as the negative 0 to 1 of the same integrand, and we know that the integral from 0 to 1 is pi over 4. We computed that today as pi over 4. Is everybody okay? Is that okay? So it's like we are going, instead of going from A to B, we are going from B to A. Okay? So when we reverse the direction is basically it's the negative of that integral. Is everybody okay? Okay, here's another theorem. The theorem says that suppose that the integral from a to c is defined, and also the integral from c to b is defined. So there are a, c, and b. They are three numbers, and I know that the integral of f from a to c is defined. Integral of f from c to b is also defined. Okay. The question is, what's the if I know that they exist, then what I know is that the integral from a to b exists, and not only that, I can say that the integral from a to c plus the integral from c to b is the same as the integral from a to b. So sort of if you look at c here, right, the c here and the c here, they match. Yeah. Yeah. So the integral from a to b is the same as the integral from a to c plus the integral from c to b. So the upper limit of the first integral is the same as the lower limit of the second integral, right? Then you can reduce the two integrals into one by taking the integral from the lower limit of the first integral up to the upper limit of the second integral, right? If you're going from a to b. Geometrically, it sort of makes sense why it should be true, but I'm not giving you a proof of it. Just geometrically how it looks like. So imagine that this blue curve, that's the graph of the function f of x. Okay, and let's just say f is non-negative, just so it's easy to see what's going on. And so imagine you have the interval from a to b, and c is some number in between, right? But c doesn't have to be in between, but this case is easy to visualize. So if I look at c between a and b, right, what is the integral from a to c? The integral from a to c represents the red area, right? You guys agree with that? And integral from C to B gives you the green area, right? So notice that if you add them, if you add the red area and the green area, you get the entire area from A to B, right? Which is what? Which is the integral from A to B. So the integral from A to B, gives you the entire area, right? Integral from A to C gives you the red area. Integral from C to B gives you the green area, right? So basically your theorem is simply saying that, right? You're breaking up the area. Does that make sense? Okay. The integral from A to C and the integral from C to B, if you add them, it reduces to integral from A to B. Is everybody okay with that? Okay, so here's a question. Suppose that you have a integral from 0 to 10 of f of x. You are given that the integral from 0 to 10 of f is 17. You are given that the integral from 0 to 8 of f is 12. Okay? And then you are asked to find the integral from 8 to 10 of f. So you know the integral from 0 to 10. You know the integral from 0 to 8. You need to find the integral from 8 to 10. Is that okay? Is the question clear? You know the value of the integral from 0 to 10. You know the value of the integral from 0 to 8. You need to find the value of the integral from 8 to 10. How would I do it? Well, by applying the previous formula that we have. What do we know? Well, we know that the integral from 0 to 10, right? The integral from 0 to 10 is the same as the integral from 0 to 8 plus the integral from 8 to 10, right? So the integral from 0 to 10 can be broken up as 0 to 8, 8 to 10, right? These two numbers must match, right? That's how our previous formula says. A to C, C to B, right? Then you can write it as A to B. So the integral from 0 to 10, you can break it up at 8 and say that it's the integral from 0 to 8 plus the integral from 8 to 10. Well, what do we know here? We know this guy. We know this guy. We need to find this guy, right? We need to find this guy. Well, we just solve for it, right? So if I'm going to subtract this integral from both sides, and then I get 0 to 10 minus 0 to 8 is the same as the integral from 8 to 10. So what's the value of this guy? Well, we know that the value from 0 to 10 is 17. The value from 0 to 8 is 12. You subtract, you get the answer. Is that making sense? So in your homework, if you see a problem where the problem is asking you to do the same thing, that it's going to give you the value of two integrals, and it's going to ask you to find the value of another integral with the same integrand. So this is what you need to do. So you can, the main point of the problem is you can break up the integral from 0 to 10. You can break it up into two integrals, 0 to 8, 8 to 10. Okay, you can always do that. Everybody's okay? Well, you can always do that given that the integrals are defined. Did you guys need time to write it out? Everybody is done writing it out? Okay. Some more properties. If f is a non-negative function for x between a and b, here a is less than b, then the integral of f from a to b has to be non-negative as well. So number one basically says if the integrand is non-negative, then the integral must be non-negative as well. If the integrand is non-negative, then the value of the integral should be non-negative as well, but the definite integral. Does it make sense, number one? What is your intuition? Well, yeah, it does make sense, because remember, if f is non-negative, then the integral represents what? The integral represents the area below the graph above the interval from a to b, right? Well, that area is positive, right? Or non-negative, I should say. And so the integral is non-negative. If f is non-negative, the integral is non-negative. Is that making sense? Another way of seeing it, if you have a non-negative function, right? If you look at the Riemann sum, right? F of wi times delta xi, each summand is what? Each summand is non-negative, right? If I look at the Riemann sum of this function f from a to b, right? Each Riemann sum will be non-negative, because f of wi will be non-negative, right? So all the Riemann sums are non-negative. So if you take their limit, whatever value you get, it's got to be non-negative. It couldn't be negative, right? It's got to be non-negative. Am I making sense? What is number 2 telling you? Number 2 says, suppose f of x is larger than g of x. Now here, f and g may not be positive, or they might have positive and negative values. But f is always bigger than g. So f of x is always bigger than g of x for x between a and b. So what does that mean? It means that the graph of f lies above the graph of g on the interval from a to b, right? So when that happens, then the integral of f is always bigger than the integral of g. If f is bigger than g, the integral of f is always bigger than the integral of g. Does that make sense? Just think about it in this way. Suppose that f and g, they represent speed functions, both of them. And suppose f and g are speed functions. So let's say f is the speed function for I don't know, for a rabbit, let's say, and g of x is the speed function for a turtle. Okay, so the speed function for the rabbit is bigger than the speed function for the turtle. Then who's gonna? So if you look at over a time interval, who's gonna cover more distance? Well, the rabbit is gonna cover more distance because its speed function is bigger than the speed function of the turtle, right? Am I making sense? Unless the rabbit is sleeping or something in the middle of. So, but we are saying that the speed function is bigger, right? The speed function being bigger tells you that it's not doing anything else, right? Okay, but that's how you can think of it. Think of this is that if the integrand if one integrand is bigger than another integrand, then the integral is bigger than the other integral. Okay, so ignore my bad examples. I'm just reading too many rhymes to my kid nowadays. So okay, so the next example is to use those comparison results. Let's say we are looking at the integral from 1 to 4 of root x dx. We're looking at the integral from 1 to 4 of root x dx. At this point, we don't know how to compute this. We don't know what's the exact value of this integral at this point. I cannot interpret this integral as an area. I can interpret, but I cannot find the value of the area. So what is the value of this integral? Well, it's the area. So this is the graph of root x, right? And what's the value of this integral? Well, it's this area here, right? You agree? You agree that that's the area? It's the area below the graph of root x between 1 and 4. But I don't have a formula for coming up with that area, so I cannot tell you what this definite integral is by computing the area. Am I making sense? But pretty soon we will see how to compute this integral exactly when we get to section 4.3. But right now what I want to do is I want to do the following. I want to estimate the value of this integral. Estimate. So some crude estimate here. So how would I estimate this? Well, I can estimate this by saying the following. When x is between 1 and 4, what can I say about root x? I can say that the root x is between 1 and what? If x is between 1 and 4, then if I take the root of 1, root of x, root of 4, right? I still get the same inequalities, right? So if x is between 1 and 4, then root of x will be between what? 1 and 2, right? Well, because of these inequalities, now I integrate each side. So if I integrate now, I take the integral of 1 from 1 to 4. That would be less than the integral of root x from 1 to 4. That would be less than the integral from 1 to 4 of 2, right? Do I know what's the integral of 1? Remember, for a constant function, we know the exact value, right? It is what? 1 times 4 minus 1, right? What's the integral of c from a to b? It's c times b minus a, right? So the integral of 1 is just 3, right? 1 times 4 minus 1. What's the integral of 2? Well, that's 2 times 4 minus 1, which is 6. So what can I say? I can say that this integral that I had, this is between 3 and what? Was that 8? 6, sorry, 6. This should be 6. So I know that the value of this integral is between 3 and 6. So that's just a crude estimate by using an upper bound and a lower bound for the function root x. We know that the root x is greater than 1 if x is bigger than 1, and root x is less than 2 if x is less than 4. Right? So by using those estimates, by using the fact that root x is between 1 and 2, when x is between 1 and 4, I can say that the integral of root x between 1 and 4 is between 3 and 6. And let's see geometrically what that means is that what's the integral of 1 from 1 to 4? If you think about it, the integral of, so this is the height 1, okay? This is height 1. This is height 1. So integral of the constant function 1 gives you this area here, right? You agree with that? And this is height 2. What's the integral of the constant function 2? It's giving you the green area, right? So the area below x squared, the area below root of x between 1 and 4, the area below root of x between 1 and 4 is bounded above by the area below 2, bounded below by the area below 1, right? Am I making sense? So you can see the area below root x is between the area below 1 and area below 2. And area below 2 is exactly 6. Area below 1 is exactly 3. Is everybody okay with that? Okay, you guys are giving me 10 minutes today? Okay. Remember some time ago I said if f is continuous over an interval from a to b, then the function has to be then the integral must exist. Integral will exist if the function is continuous. But we can relax the condition of continuity a little bit. For example, if I know that the function is piecewise continuous. So what do I mean by piecewise continuous? What do I mean when I say that the function f is piecewise continuous on an interval? What I mean is that the function is not continuous on the entire interval, but it has only finitely many jump discontinuities. So a function is called piecewise continuous if it has only finitely many jump discontinuities. So a piecewise continuous function may look like this. Okay? So it's not continuous everywhere, but it has only finitely many jump discontinuities. Now, remember we can also have infinite discontinuities, like, right, where we have vertical asymptotes. That's not a jump discontinuity. Jump discontinuity means this. Okay? So a piecewise continuous function means it's a function where it has only finitely many jump discontinuities, okay, on the given interval, only finitely many. So if I have a function which is like this, then the definite integral exists. What is geometrically? What does the integral of this function represent? You think? Geometrically, what does the integral of this function represent? Area here plus the area here plus the area here, right? Oops. Is everybody okay? So if I have a piecewise continuous function on an interval from a to b, then the integral will exist. Okay, and that's what I am trying to say here. If I know that f is continuous or piecewise continuous function, then the integral must exist. Okay, f is integrable on the interval from a to b. Did you guys need a little bit of time to write it out? So go ahead and write it out. And that's the statement, or I should call it a theorem. If f is continuous or piecewise continuous on an interval from a to b, then f is said to be integrable on that interval. Integrable means that the integral from a to b of f exists, right? Integrable means that integral of f from a to b is defined. Okay, you guys are done writing it out?